Okay, I got cut off in that last video, but I want you to pause this video and attempt these problems before I go over them. That way you can try them on your own, and then we can come back together and go over them. So if you haven't already, please pause and attempt this first problem. Once you're done with that, come on back. All right. So in this sample EOC problem, it says angle P in Q, and right there it's P to N to Q. So PNQ is an inscribed angle within circle O. So we already knew that was an inscribed angle just by looking at it, right? But circle O, that tells us that O is the center point. Remember, circles are always named after their center point. So O, any angle with O is going to be a central angle. And now it also tells us that the measure of arc PQ, so see that semicircle up at the top, that means arc PQ is 70 degrees. All right, so we have three separate questions. This isn't a multiple choice question. All right, let me zoom in. So A, what is the measure of POQ? So looking at this, we're trying to find POQ. So we already said any measure with angle O is going to be a central angle because O is the center, right? So angle POQ is going to be a central angle. And we know that the rule with central angles are that they're equal to the arc, right? So if the central angle is equal to the arc, that would mean that POQ is 70 degrees because our arc is 70 degrees. All right, let's go ahead and do part B. What is the relationship between POQ, so that's central angle, right, and PNQ, which is the inscribed angle. So looking at it, these angles share an intercepted arc. See, POQ, its intercepted arc is PQ, and the same with PNQ, right? So that means that angle POQ is 70, and angle PNQ must be half of 70 because it's an inscribed angle, right? So that means PNQ is equal to 70 divided by 2, which is 35. So I'll say, to summarize, POQ is twice the amount, twice the measure of angle PNQ. You could also say the converse of that or the reverse of that. Angle PNQ is half the measure of angle POQ. We just need to know that this is the smaller angle, right? PNQ is smaller than POQ. All right, and then I think we answered part C because I got ahead of myself. The angle PNQ is going to be 70 divided by 2, which is 35 degrees. All right. Nice work. All right, before you attempt the next one, let me just go ahead and explain how this question works. It says select 3 statements that are true about the figure. So out of these 6 options, you should circle 3 true statements. So go ahead, look at the picture, analyze the statements, select your answers, and then come back and we will go over it together. Okay, I hope you attempted this next one on your own. So what we're going to do is we're going to take a look at the picture, we'll make some statements about what we see about the picture, and then we'll go through and evaluate each answer choice and either eliminate it or say it's true. So looking at this, figure C has 2 tangent lines, right? QR and SR. So automatically we know wherever a tangent and a radius intersect at the point of tangency, that's a right angle. So I'd have a right angle here and a right angle here. The measure of QCS is x. So automatically I would know that QS is also x, right? Because the central angle is equal to the arc. And then I've got an inscribed angle here that hits the same arc. So that inscribed angle would be x divided by 2. It'd be half of that arc. All right, since we looked at all that, let's go ahead and look at our statements. So number 1. The measure of angle QPS is 90 minus x degrees. No, we said it would be x divided by 2, but there's nothing about 90, so that's not a true statement. B says the measure of QPS is 1/2 x, which is the same thing as writing x divided by 2. So B is true. 1/2 x and x divided by 2 are the same thing, right? All right, C, the measure of angle PSR is 90 degrees. I bet you were tempted to put that, right? But look, PS is not a radius. Remember, a right angle is only formed with a radius and a tangent. So if the answer choice had said CSR, that would be true, but it says PSR, so I cannot say that's true. All right, answer choice D, CQR is 90 degrees. That's a true statement because CQ is a radius, and it intersects at the point of tangency with that tangent line. So D is true. All right, E, the measure of QRS, so it's this outside angle, is 180 minus x. All right, so we know that two tangent lines form a circumscribed angle, right? Oops, I'm out of the circumscribed angle. So looking back at our first page, we said that the circumscribed angle is 180 minus the intercepted arc, right? So looking at this, our angle would be 180 minus x because our arc QS is x. Central angle and the arc are equal. So E is my correct answer, which means F is not true. All right. Let's go ahead and move on to this next question. Again, I want you to pause the video, try it on your own, and then come back and we'll go over it together. All right, I hope you paused the video and you've worked everything out. Let's go over this. So the spokes of a bicycle wheel form 10 congruent central angles. All right, this is important to know because this is the center of the circle and all 10 of these angles are equal. So we can figure out what the angles would be. The entire circle is 360 degrees. If every angle is equal, and I've got 10 of them, I can divide 360 by 10 to figure out what each angle measurement is. 360 divided by 10 is 36 degrees. And we could test ourselves by adding up all these angles, and it would add up to 360. All right, the diameter of the circle formed by the outer edges of the wheel, so the diameter, is equal to 18 inches. If we know the diameter, we know the radius. If our diameter is 18, our radius is 18 divided by 2, which would be 9 inches. All right, I think we have enough information to start the problem. What is the length to the nearest tenth of an inch? So 10 has 1 0, which would mean 1 decimal place, of the outer edge of the wheel between two consecutive spokes. So that word consecutive, it means one after the other. So I could do this spoke and this spoke, right? Because that's one after the other. Basically, it's asking us for the arc length of each piece. They would all be equal because every single one of these arc lengths has the same radius and the same central angle. So we can just calculate one of them. So what I need, I know that I'm looking for arc length, which is abbreviated by S. And if I go back to the first page, I can find our formula here. So S is equal to 2 pi r theta divided by 360. So the two things we needed were the radius and the central angle. I think we have those. So radius is 9 inches, and we said our theta is 36 inches. I'm sorry, 36 degrees. So we can plug all this in. S is equal to 2 pi 9 36 divided by 360. And let's plug all this into Desmos. So you can either do this on your Desmos app, or you can go to desmos.com. All right, so looking at this, I'm going to do 2 pi All right, I hit the division sign to get the fraction, and then I move the little arrow back up to get to the numerator. So 2 pi 9 36, and then click on that little box below, and I've put 360. Again, you need to make sure that you're in degrees on Desmos. So go ahead and click the wrench and switch to degrees. All right, remember we need to round to 1 decimal place. So 5.7, right? Because that 5 would bump the 6 up. So 5.7 inches, which is B. Answer choice B. All right. All right, go ahead and pause the video and attempt this next question up here. Come back once you've looked over it and attempted it. All right, so hopefully you've attempted this next question already, and we're just going over it. So it tells us circle Y is shown below. So we automatically know Y is the center of the circle. All right, what is the area of the shaded part of the circle? So I'm looking for this area, the shaded part. So area of a sector, I'm going to go back to that very first page to get the formula. And our area of a sector formula is going to be pi r squared theta over 360. So the two things I need are the radius and the angle. All right, so it gives us the radius of 9 centimeters. We know it's the radius because it goes from the center to the outside. And it gives us the central angle, but it gives us the central angle for the non-shaded part. I need the angle for the shaded part. So what I would do here is I would do 360 minus 75, because 360 is the entire circle. So if the non-shaded part is 75, then I can calculate the shaded part, which would be 285, because they must add up to 360. All right. Now we're ready to plug it in. Area is going to equal pi 9 squared 285 divided by 360. All right. So now we can solve this in one of two ways. Our calculator used to give us our answers in terms of pi, but we don't have access to the calculators right now. So what we can do is we can plug this in and give a decimal and see what decimal goes with the answer we got. So I'll do that first, and then after that I'll show you how to simplify this into one of these answer choices. So for now, let's just go ahead and get the decimal on Desmos. So pi divided by, I'll go back up to the top, 9 squared times 285 all over 360. Make sure you're in degrees. All right, so that's going to give me a decimal of 201.45. Now let's go ahead and put these answer choices in the same format. So 57 divided by 4 pi is going to give me a decimal of 44.77. All right, our next answer choice, 135. 135 divided by 8 is going to give me 53.01. So let's keep working. Our next one of 405 divided by 8 times pi is going to give me 159.04. And this one of 513 divided by 8 times pi is going to give me 201.45. So looking at that, we can see that D is our answer choice. All right, I'm going to end the video here because I'm running out of time, but go back to log on to the next video, part 3, and I'll walk you through how we can simplify these numbers without converting the answer choices to decimals.